Sample problem 11-04. A student is holding a meter stick by one end. A 1,000-gram mass, also known as a kilogram, is hung on the meter stick. All of the meter sticks are identical, but the distance along the meter stick at which the 1 kilogram mass is hung and the angles at which the student holds the meter stick vary. Ignore the mass of the meter stick itself. So what we want to do here is we want to rank the difficulty of holding the meter stick from the left end in the position shown, which in essence says which ones are getting, we really want to say which one is the greatest torque. Right, that this is the same as saying rank the torques, because the one that exerts the highest torque requires the highest counter torque from the student, which is the hardest to hold. And so we go back to that the torque is always just R perpendicular times F, where F is the force, so and R perpendicular is the perpendicular distance between the line of action and the pivot point. So I'm going to jump to, as our standard one, I'm going to go to E first, because it's the simplest case. And E, in case E, the force is clearly, in fact, in all of these cases, the force is just mg, and so it's whatever the weight of 1,000 grams is, 9.81 newtons. But I'm just gonna call it F, to be honest. They're all gonna scale with it, so I'm not gonna care. They all have the same force. What matters here is gonna be the perpendicular distance. So the line of action for E is the line that contains the force. And we can see the force is obviously that, so the line containing the force is that, and that distance I'm going to call L, the length of the meter stick. So the torque in E is F times L, and that's going to be our basic guy for comparison for all of them. They're going to be in terms of FL. All right, so then I'm going to jump and say, in fact, let's start making a chart somewhere and say we're going to have a chart that says the torque for A, B, C, D, and E. And for E, we just discovered that it's FL. And I'm going to jump to B, because that one's relatively simple as well. In B, we have, this is the force, so the line of action is that, and therefore they show us conveniently enough that the distance, R perpendicular, is L over 2. And so the torque is going to be F times 1/2 L, which is 1/2 FL. So we already see that E is more than B. Sadly, for the rest of them, we actually have to do some honest-to-God work and not fake it. So if we look at A, we say this is the line of action for A, so this is the distance I care about. Remember that distance is L. And we can see that the thing we want, R perpendicular over L, is the adjacent over the hypotenuse, and therefore I can say that this is the cosine of 30. And the cosine of 30 degrees is √3 over 2. So our perpendicular is √3 over 2L, which is about 0.86 L. And therefore, if we go back over here, for A, it's going to be a force F times about 0.86 L, which of course is 0.86 FL. And then, let's see, color. For C, this is the line of action, and this is the distance I want, and that's L, and that's my angle. And now I have to say, oh, wait a minute, so now R perpendicular over L for that one is now the opposite side over the hypotenuse, which we know is the sine. Of course, the sine of 60 is the cosine of 30, because that's how sine and cosine are related. So this is actually going to give me the same F times 0.86 L, or 0.86 FL. And then finally D. The line of action for D is this. R perpendicular is this. And so R perpendicular over L is an adjacent side over hypotenuse. That's cos of 45, which is about 7.1. About something like that. So F times 0.71 L or 0.71 L. And now we can just look and say that clearly the largest is E, and the next largest is either A or C, because they're the same, and then D, and then finally B. So this is our final ranking.